When it comes to validating numbers, there are a number of different things to look out for. Much like our previous effort, we're reading a string in from the keyboard via the console. So there's two potential problems here. Firstly, the string itself might be problematic. It might be too long, too short, empty, so on and so forth. So ignoring the contents of the string itself might be a problem. So in this case, we do something very similar to the previous example. We're going to check and say if the person's age as a string is empty, it's not going to work for us. If there are too many characters in the string, this could also be a problem. If the length is okay, we're now at the point where we want to try and turn the input string into a number. This is typically the thing that people test for and ignore the fact that the string itself might be a problem. So in this case, what we're going to attempt to do is try and pass the person age as a string into a person age which is of the type integer. So this function will return, the try pass function will return a result of a Boolean result of true or false. In this case, we're going to say if this equals true. So in fact, as per my previous point about making code easy to read, let's say equals to true. So if the attempted passing of the string into an output integer is successful, then the person age is valid. If it is not, the input string was not able to be converted to an integer. So in this case, just for debugging purposes, let's make this number smaller, 8 digits. So let's run our program again. Take a second for it to compile. So we now have a person's name. If it's too short, it doesn't work. Or if it's empty, it doesn't work. So we have a person, and now we have a person age. Should I enter an empty one? Input string too short. So age does not work. If we now enter a number that is too long, a string that is too long, string is too long. Not a valid number, but now we're checking to see if the string itself is a problem. In this case, if we were then to put in numbers that are longer than 8 digits, still too long, we don't fail the attempt to convert it to a number because we don't even try and convert that to a number because that number is too large to fit into an integer 32. But in the case of having a correct integer, well, let's say 45, we continue on to the next portion. So this means that for both the username and for the integer person age, we've been quite robust about testing both the input string for validity and for the type of data that is contained in it and the range of that data. So the next thing we would want to add to the validation of person age is that it is not a negative number and it's not a number of like 900 years old. So we would just continue adding things to make this more and more robust. So this is the difference between business rules and programming language rules. There's a maximum size for an integer in C# and maximum in 32 is of a certain size. So in our case, if we cancel this and we say, we try and pass that and it does actually work, we end up with an integer. So if the integer let's say if the person age is greater than half of an int 32 dot maximum value, then we want to say very large age value detected. So in this case, the maximum value for this is going to be a constant that's defined by the programming language itself. We'll be able to see what that is, and if we looked up the documentation. But in this case, let's make this a large string again, so that we can put in a ridiculously large number. So in this case, if our number is too high, we cancel that. I've already seen a mistake here. And obviously we have to have a condition somewhere where we actually consider it to be a valid age. So if we now run this and we put a very large number in, whilst it is considered a valid number, it might be too large and we want to protect against it. So in this case, what we're doing is protecting against overflowing the amount of space available for a number of an integer 32 data type. So in this case, if we did something like this, it's fewer than 64 digits, but it is also a very large number. So we're unable to convert that to a number. The parsing has failed. So this is actually a belt and braces thing. What's happened here is the try parse has tried to convert to a 32-bit minimum or maximum value, and what we can see here is that greater than the value, the parameter will be uninitialized, and the original value will not be overwritten. And that's because this try parse has in fact failed because the number is too large. So this one was redundant, this example was redundant because you can't actually have a successful attempt to parse a number that large. So we would have to pick a number that is halfway between a maximum int 32 and above halfway, but not bigger than the maximum value. So I'd have to look it up to test it. Anyway, that's not an important example. The important thing here is that we test for every conceivable issue that might arise when a person enters data. So like I mentioned before, there is another technique that we can use to catch any other unforeseen error. So in this case, we're looking for things like length too large, no data entered, the data can't be turned from a string into the integer that we require. So we're dealing with all of those things one at a time. There is a catch-all technique that says if there is a problem here that is unrecoverable, then instead of crashing the program, do something with it. And in the case of C#, that is the try-catch finally setup. So we try a particular set of methods or functions. If one of them throws what's called an exception, so an unrecoverable error, then the catch clause in that three statements will then be executed immediately. In that case, you could give the user an error, process a message, or something of that nature, and then the finally section runs whatever code you need to clean up from the problem or an attempt to re-trigger or retry. So a common scenario might be that you attempt to write to a database. The database doesn't respond, so you catch a timeout error. When that error occurs, you set some value that says, we've had an error, we set some message on the screen or so on, and then we process with the finally clause either an attempt to retry and do it again maybe 3 times, or cleaning up the data and removing any data that's sort of half complete and orphaned, or whatever you choose to do. But try, catch, and finally are the methods and functions that we use to protect against those unrecoverable and unpredicted errors in C#. However, you should not use them for program flow control. So do not try and open files, for example, and then say, if there's an exception occurs, file not found, then do something else. Check to see if the file exists. Do not use the exception handling as flow control. That is a hallmark of bad programming in the .NET environment, and generally speaking, exceptions and critical errors should not be used for controlling the flow of your program. You should avoid those errors and then deal with the unrecoverable errors in the safest way possible, but not use them to control the way your program works.